Sheet metal is an inexpensive and versatile method of manufacture and is ideal for creating brackets, cases and covers. When designing industrial, medical or lab equipment, or anything that requires a sheet metal enclosure, Onshape's unique multi-part part studios, in-context assembly design tools, and sheet metal design tools streamline the process from start to finish. To create a sheet metal part, open a part studio and select Sheet Metal Model. This feature does two things. First, it defines your default sheet metal parameters such as thickness, bend radius, and K-factor, which is used to determine the bend allowance. You can also define the default corner condition where two or more bends meet, and the default bend relief type. Second, this feature controls all the subsequent sheet metal features that are added to this part. There are three ways you can create your first sheet metal feature. You can convert a solid, extrude a sketch, or thicken a face. Converting a solid that represents a space envelope around the components in your assembly is a very efficient way of building complex sheet metal parts. Material is added to each face, and you can choose if your space envelope is either internal or external. You can then select which faces to remove and which edges to bend. Defining which edges to bend and which edges to rip determines how your part will look and how it will be manufactured, so choose carefully. When you select an edge, a bend is created. Select another edge and a corner is created with two bends, a rip, and a default corner condition. This can be changed for the entire sheet metal model at any time. Using a closed corner makes the part easier to weld after fabrication. Continue adding bends and rips until every face is connected to the sheet metal part. Every time a new bend is added, Onshape is calculating the flat pattern in the background, so if any of the bends you select are invalid, Onshape lets you know right away, so you can keep trying different combinations of bends and rips until you get a good, valid result. Selecting this front edge also gives an invalid flat pattern, but we'll leave that for now to take a look at some of the other tools at your disposal. As soon as you create a new sheet metal part, a tab appears on the right hand side of the graphics area. When you click it, a panel opens to display the flat pattern of the sheet metal part. Here you can clearly see the area of interference. To help you navigate around the part and to find the areas that are causing problems, edges and faces highlighted on the flat pattern are also highlighted in the 3D view and vice versa. Above the flat pattern are two tables, one for bends and one for rips. You can keep this panel open while you design, so you can instantly check to see if your part is manufacturable. To fix this collision, simply edit the bends that were added when converting the solid to sheet metal by unselecting the faulty bends and trying some other combination. This set of bends gives us a valid flat pattern, as does this one. But you might not want a welded edge to be visible to the end user, so we'll move the split edge into the centre. This still creates a small gap at the intersection, but that can be fixed later. Finally, repeat the bends on the other side and the flat pattern is now complete. Since this design will also need a cover, you can keep the space envelope model and reuse it later. Now to add some flanges. A flange can be added to any straight, open edge of a sheet metal model. Which edge you select, inner or outer, makes no difference. The length of the flange is measured from the tip to the virtual sharp. You can set the distance to be blind, up to entity, or offset from entity. You can also specify how the flange should be aligned, either inner face, outer face, or middle. Keep the automatic miter option checked if you are going to add more than one flange, and the bend radius is taken from the sheet metal model feature. By default, the bend angle is 90 degrees to the edge you selected. As soon as you select another edge, both flanges are automatically mitered to prevent interference, and the sheet metal flat pattern is also updated. You can add as many flanges as you like in a single feature and create complex sheet metal parts in a matter of minutes. Once all the flanges are added, there's no need to check the flat pattern. You can see it right there. Let's take a look at what you can do with the tables. Each bend is listed with its bend order, radius and angle. You can change the bend order, modify its radius, or convert it to a rip. Changing the radius of a bend automatically fixes up the corners, and the flat pattern is of course also updated. This gives you complete control over every aspect of your sheet metal design. For each rip, you can decide if you want the edges to just touch, or whether you want one edge to overlap the other for a better joint. Simply find the rip you want to adjust and choose from one of the options. You may need to try both direction options to get the overlap you're looking for. The bend table contains every bend in the model, making it easy to override each bend radius and define bend order. The corner feature allows you to override the default corner type. You can change the corner style, and for round and rectangular corners, change the corner scale. In this case, we'll keep it simple. It's also possible to modify a rip or close a joint using the Make Joint feature. This feature behaves in a similar way to the rip table, giving you the option to create an edge joint or a butt joint in either direction. Let's finish this model off by adding one more Make Joint feature so that the part is symmetrical. Now let's create another sheet metal part using a different method. This time we'll use Thicken. This works in much the same way as Convert, but with Thicken you can select solid, surface and sketch faces. We'll reuse the top faces from the Space Envelope model and select the single edge as a bend. You can see that this cover is interfering with the case. This can be easily fixed by applying an offset equal to the material thickness of the other part. Now that the cover is on, you can see that there's a gap, so we just need one last edit to the flange arrangement on the case. You can add more flanges or you can edit an existing one. Since this flange is part of a set of flanges, the length is fixed, but you can use the regular Move Face command to stretch the flange out to the required length. Move Face can be used to change a flange length, angle or alignment, and is ideal when making a change to the original feature definition is not practical. To remove any excess material, simply use the regular Extrude Remove command. Sketch as you would do normally, making references to other edges and flanges, and extrude up to next. Now we have the final blank, but we don't yet have any of the other features required to mount the components in the assembly. So we'll go back to the assembly, assemble the parts, and use Edit in Context to see all the parts together. Now we can edit the cover and add cutouts for the LCD, the keypad, and the two heating mantles. Again, all you need to do is to create a sketch on each face, reference the edges from the in-context assembly components, and extrude remove the material from the cover. Since both sheet metal parts were designed in the same part studio, you can edit both at the same time, or you can create another context that shows only the parts you need to see, if that's easier. The final part we need is a sheet metal bracket to hold the heating mantles in place. To do this, we'll use an existing sketch and we'll use the extrude option in the sheet metal model feature. The extrude option works with single chained sketch lines only. The material can be flipped either side of the sketch lines and bends are automatically added, so there's no need to add arcs between each line. You can then extrude it blind or symmetric in the exact same way you would a normal extrude. The only difference is that all the bends, bend allowances and flat patterns are being generated for you. Now to add the cutouts. One of the benefits of working in a part studio is that you can reuse features from other parts. So to add the cutouts, simply reorder the cut feature and edit it to change the merge scope and the cut depth. In this case we'll use up to face and create a new in-context reference. While a sheet metal model is active, any cuts that are added cut normal to the sheet metal thickness as if they were added in the flat. So if we zoom in on this cut, you should just about be able to see that the top edge of the cut is in contact with the selected face. Just what we needed. The last thing we need to do to this part is to shorten the end flanges to make them into tabs. This can be easily done using the Move Face command, which recognises that the part is a sheet metal part and automatically adds bend reliefs. So far we've been adding cuts to active sheet metal parts, which creates the cut normal to the sheet metal thickness. If you want to create a cut that is not normal, then you can by adding a Finish Sheet Metal feature. Any features added after this feature are not added to the flat pattern. All this feature does is to turn a sheet metal part into a normal solid part, so you can add cuts, weld the corners, or add form features like these feet, either manually or by using a custom feature script feature. Unless you need these types of features, then you don't have to add a Finish Sheet Metal feature. Finally, if you need to generate a DXF of the flat pattern, or you need to create a drawing, open the flat pattern view, right-click and select Create Drawing of Flatten. You can then create a one-to-one view of the part and export as DXF, or detail the view with bend centerlines and dimensions. Onshape's unique sheet metal design tools, multi-part part studios, and in-context assembly design workflows help you build complex sheet metal parts, solid parts, and assemblies together and streamline the entire design process from start to finish.